Chemistry of group 4 elements. We are starting with carbon. Carbon sits in the second period of periodic table, group number 4, with neighbors boron, nitrogen, aluminum, silicon, phosphorus. It has electron configuration of helium with valence electrons 2s2, 2p2, total makes 4, and the most common rule is carbon always make 4 covalent bonds. The enormous area of carbon compounds is organic chemistry. Actually, most of chemical compounds we know are organic compounds, and all of life is organic chemistry. So which part of carbon chemistry we can touch as inorganic? The unofficial agreement is that organic compounds must have at least one carbon-hydrogen bond. Then, compounds that do not have any carbon-hydrogen bonds will belong to the area of inorganic chemistry. We'll briefly look at these compounds today. Carbon has very high melting point. Graphite decomposes by sublimation at 3700 degrees. It has relatively small atomic radius. It has relatively high electronegativity. It's more negative than positive element. Common forms or allotropes of carbon are graphite, hexagonal layers of carbon atom connected by aromatic bonds. It's something between double and single bonds. And these layers have spacing of more than 3 angstrom between them, so they easily slide one from another. Density is average 2.3. Much higher density, 3.5, is in diamond, where carbon atoms are closely packed in tetrahedra. Another form of carbon are fullerenes, relatively new compounds with very low density of 1.65. This low density is because of large empty space between these carbon atoms inside almost spherical C60 and slightly elongated C70. These forms are actually molecules because they are soluble in organic solvents. Relatively recently, around 10 years ago, one more form of carbon was discovered, which is graphene, monoatomic layer of carbon atoms, and this is actually a photo of it with atomic force microscope. Again, we have pi bonds and sigma bonds between carbon atoms. Very common misconception is that coal is one more form of carbon. Actually, it is not. Coal formation is a result of processing plant tissues in geological scale by heat, pressure, and time. So first you have peat, then you have so-called lignite, which sometimes named brown coal, and then you have usual coal. When you do coal analysis and you'll try to assign chemical formula, you'll have something like that. C100 something, hydrogen, almost 100. So ratio carbon to hydrogen is almost 1 to 1. There are also oxygen, nitrogen, and sulfur atom in usually bituminous coal. In high-grade anthracite, there is less hydrogen, so ratio carbon to hydrogen is 2.5 to 1. Usually 4 ranks of coal are anthracite, which is shining black, bituminous, black, and brownish lignite, sometimes named brown coal. Bituminous coal, as a result of great pressure applied in geological scale. This is the type most commonly used for electric power generation in the United States. It has higher heating value than lignite, slightly less than of anthracite, but it's much cheaper. Bituminous coal is mined chiefly in Midwest and Appalachia. Anthracite, or hard coal, forms from bituminous coal when a great pressure develops in geological formation. It occurs only in limited areas. In the United States, only in the Appalachian region of Pennsylvania. Anthracite has highest energy content and used to make coke, that is in turn used in steel foundry ovens. We always have sulfur admixture in coal. It can be inorganic sulfur, sulfides of iron or pyrite, like this, or it can be organic compounds of sulfur. Keep in mind that carbon atoms have hydrogens connected to them. So when we look at chemical analysis, we see that we always have around 1% to 0.5% of sulfur even in the best source of coal, and in some bituminous coals we can have up to 4% of sulfur. You also have chlorine. Usually you have some water as well. In lignite, up to 1/2 of your coal is just water. That's why heat content drops down from anthracite to lignite. Coke. Now, coke is not this and it's not this. It's a solid residue derived from low ash, low sulfur bituminous coal, from which volatile constituents are driven off by baking in oven without oxygen at temperatures around 1000 degrees Celsius. So hydrogen containing species are washed out. Coke is used as fuel and is reducing agent in smelting iron ore in a blast furnace. Coke from coal is gray, hard, and porous, and has very high heating value. Now, byproducts, this volatile stuff that runs away when you heat coal at 1000 degrees, are so-called coal gas. It's mostly hydrogen, but also there is methane, carbon monoxide, and ethylene. It can have some interest for chemical industry, but mainly used as fuel in metallurgy.